Right? What if we get uh, a problem where we have no solution? What would that look like? Well, remember, no solution will be that you get a false statement. And normally that can happen anywhere. It could be in your first step, your second step, third step, wherever you get a false statement, it means that the whole system is false. And so let's go ahead and decide where we want to start. Normally, it's easier just to pick the smallest one. It doesn't matter which one you start with, you will always get the same answer, just like we did in the regular uh, two variable system. All right, so let's look here. We have x, y, z. I will start off with this one and this third one. So the first and third one I believe would be the easiest to start with. You can start with any one. I believe this one's from the book and they use a different one. I like the first and second. So let's see what this will look like. We have x plus y plus z equals to 2. And then we have x subtract 2y plus z equals to 4. So notice we can cancel either the x or the z's first. The way to do that would be to subtract everywhere or multiply one of them by -1. You could also multiply the middle term of the first one by 2, so you could eliminate the y's, but why add another step? So instead of multiplying by -1 and then adding, I'm just going to subtract everywhere. And if you do that, x subtract x will cancel. Y subtract -2 will turn those two negatives to a positive, and that will be 3y. Z subtract z will cancel out as well, and 2 subtract 2 will be equal to -2. Right, if we divide both sides by 3, then we're going to get y equals to -2/3. So if we now do the first and the second, that means I can multiply this one by -3. And so if I do that, if we rewrite it, I'm going to have -3x multiply -3 by the first row, plus -3y plus -3z equals to -6. And then the second equation, 3x plus 3y plus 3z equals to 14. Well, we can take that and add them. That's what we'll eliminate. So the 3's will cancel, those 3's will cancel, everything's going to cancel there. Everything's going to cancel there. And so we're going to end up with 0 equals to -6 plus 14. That's going to give us 0 equals to 8. And that is a false statement. So actually, if we would have just started with the first and second one, we wouldn't have to worry about this one at all. But because that's a false statement, it means it has no solution because that second one failed. Okay, so here on page 181, this is straight from the book. Here's one where they ask you to do something using substitution. So if you were to use the substitution method to see if you had no solution, what you would do is solve for one of the variables. The third one would be the easiest to solve with because you can solve for x or z. That would be the easiest. You can also solve for y, but you're going to end up with some fractions. So if you want to solve for x, remember you just subtract the 2y and the z on both sides, and you're going to end up with -2y subtract z plus 4. Now you could take that x equals and substitute it into one of the other variables. And you could try the first one. And so if I substitute this x into the first one, I'm going to have -2 times, I'm substituting this whole expression in there, -2y minus z plus 4. Right, that's what I put in for x, plus my y plus 3z equals to -8. Right, we're going to distribute our term in there, so that's going to be 4y. -2 times -z would be plus 2z. -2 times that 4 is going to give us -8. Plus y plus 3z equals to -8. All right, then we can collect like terms. Starting with the y's, we're going to have 5y. If we go to the z's, we're going to have plus 5z. And then we're going to have -8 equals to -8. All right, then we can bring those 8's over, and we're going to have 5y plus 5z equals to 0 when we add the 8 on either side. All right, then we can substitute it into the other equation as well, into the second one. If we do that, we're going to have 3 times -2y subtract z plus 4 and plus 4y subtract 2z equals to 9. All right, so we can distribute that in there as well. 3 times negative 2y become negative 6y. 3 times the z, that's going to give us 3 minus 3z. And then 3 times the 4, that gives us positive 12. And then we just write out everything else. Alright, so then we can collect like terms. If we start with the y, we're going to end up with negative 2y when we do negative 6y plus 4y. With the z's, we're going to end up with negative 5z, and then plus 12 equals to 9. If we subtract the 12 on both sides, it will cancel on the left. And then on the right, 9 subtract 12 would be negative 3. So now we have two new equations there, and we could go ahead and eliminate those and see what happens. So we have 5. I want to change that color. So now if we use those two new ones, we have 5y plus 5z equals to 0, and then negative 2y minus 5z. And you notice they're already the same, so there's nothing else I have to do to that. Subtract 3. Right, so in order to cancel that, we have to add everywhere. That would cancel the two middle terms. And then 5y subtract 2y is going to give us 3y. And 0 subtract 3 will give us negative 3. And divide both sides by 3. And you get y equals to negative 1. Alright, so this title had no solution, but this one actually does have a solution. So just ignore that title. We now have y equals to negative 1, and we can just substitute back into our one of our z equations there. And so if we do that, we have, we can substitute into the first one. We have 5y, the first new one, plus 5z equals to 0. Replacing that y with a negative 1 would be negative 5 plus 5z equals to 0. And we have 5z equals to 5, bringing that 5 over, and z would therefore be equal to 1. So we have z equals to 1, y equals to negative 1, and then we just need to find our last one. And we could do that by using our x equals. And if we do that, just draw a little space here. We're going to have x is equal to negative 2 times negative 1, that's our y, subtract z, which is 1, plus 4. So x is going to be equal to positive 2 minus 1 plus 4. That's going to be x equals to 1 plus 4. So therefore x equals to 5. All right, so that's what our ordered pair would be. Ordered pair would be 5, negative 1, and then 1. Or x equals to 5, y equals to negative 1, z equals to 1 as our final answer. So this one had the wrong title. It does have a solution, and this is how you would do it if you were asked to show your working via the substitution method. All right, so in example 3, we're going to do a system with many solutions, infinitely many solutions. All right, so we can start off with the first and second one. We can already see that would be the easiest to work with. We don't have to change anything, and we could decide which one we're going to eliminate, the x's and the y's together, just so that we can get z, or we can eliminate the z so we can find out what our x and y's are. In doing the z, although you get your z, it could make a little bit more work, but I'm going to go ahead and do that one. We're going to eliminate the z's and then see what happens with our x, y. All right, so we're going to go ahead and if we rewrite that, we have x plus y plus z equals to 2. And one reason I'm choosing to do it this way, it's different than the book, so you can see different methods. All right, so we can simply add everywhere, and that will eliminate what we get there for the z's. I actually think they did the same way. So we have 2x plus 2y equals to 4. And we could simplify that down if we wanted to, but we're just going to continue now. We're going to choose two more, the second equation and the third, or the first equation and the third. I'm going to go with the first equation and the third. So we have x plus y plus z, and we want to eliminate the z's there, equals to 2. And so we have 2x plus 2y plus z equals to 4. And the reason why I didn't multiply is because we can just subtract everywhere. And sometimes it's easier to write the bigger one first. Anyway, we have x subtract 2x. It's going to give us negative x. Y subtract 2y. It's going to give us negative y. The z's will cancel. 2 subtract 4 equals to negative 2. All right, so now that we have that, we can go ahead and see what happens when we put those two together. So we have our new equation 1 and new equation 2. So we have 2x plus 2y equals to 4. And then we have negative x plus negative y equals to negative 2. We're going to have to multiply. So I have to just do that, edit that. Alright, so before I write the second one, we can modify that. If we multiply it by 2 there, everywhere, we're going to get 2 times negative x is going to be negative 2x. And we're multiplying by 2 because we can eliminate the x's. If we multiply the negative y, we get negative 2y. And then the other one would be negative 4. And notice if we do that, if we cancel that, well, we're going to get everything cancels down to 0 equals to 0. And there we have the identity. And once we get the identity, we know what our solution will be. And so because we have the identity, we have infinitely many solutions. And so any solution will work. Now, if you wanted a form where we can represent this in coordinate form of the different points that can work, then what we can do is solve one of our basic equations for y. It would be easier to use the blue one, so let me put that in blue. And so this is a alternate thing that we can do, and sometimes you're asked to do. If we were to solve negative x plus negative y equals to negative 2 for y, bringing that negative x over, we'll make it a positive x. So we have negative y equals to positive x subtract 2, but we want our y to be positive, and so we multiply everything on the right side by negative. And so we end up with negative x plus 2. So if we were to now take this and substitute it, we'll see that our y value will be anything of the form negative x plus 2. If we wanted everything to be in the form, an easy to read form, what we could do now is substitute the y equals to negative x plus 2 back into one of the original equations. If we choose the first one and we use our substitution method, we will have x, and we're replacing y, so let me put it in parentheses so it stands out, negative x plus 2, and then the plus z equals to 0. And so if we add those together, what we're going to get is negative x plus a negative x will cancel out together, and we're going to get 2 plus z. That should be a z there. We're going to have z plus 2 equals to 0. We're going to have z plus 2 equals to 2 rather. And if we subtract on both sides, we get z equals to 0. So we have y equals to negative x plus 2, one way that we could represent it. We have z equals to 0. And then we just need a form of writing the x. So that means any x that we choose can be substituted, and it will give us our y because we'll have negative x plus 2. And then we know that our z equals to 0. So anything of that form will make it work as well. So sometimes you're asked to write that solution in terms of coordinate points, and if you need to do that, that's all you would need to do.